Welcome to week 6 with Level C Math. If we scroll down in our weekly foldouts, last week we did a bunch of stuff in Mad Science with measurement, and then we played with these 4 handouts on our Thursday second class. This week we are doing the last of Mad Science, pushing things together to see what comes out, and then we will start Justice, the next topic, where you do the same thing to both sides of an equation. I also want to start having presentations happen next class, so we'll talk about that some. So we'll come back to the syllabus in a bit. When we had class on Thursday, there were a few order of operation problems that people wanted to save for today, so they could have the weekend to work on them without me giving hints to see if they could do them themselves. So if you worked on those, then feel free to show off very soon, but not quite yet. And that's the kind of announcement-y part of old things. So for big review, if you hit welcome, then our class has 3 foundational topics: everything you do with one number, combining numbers together, and equations, with the silly nicknames of shape-shifting, mad science, and justice. And then there are 4 categories of applications: things about describing data, averages, charts, probability is all grouped together as typicality, and then health decisions, personal finance decisions, and business decisions. So that's up here at the top. We have done all of the first one, everything we do with one number. We're almost done with the second one. We just have to talk about prisms, although we will review the other things also. And we have not yet started the third one. The third one sometimes goes by pretty quickly, depending on the class, because a lot of people have seen cross multiplying before and are good at it already. And almost everything we do with fractions and percentages for equations, you can wind up doing with cross multiplying. The measurement can be a little tricky again at the end. So that's what we're doing for now. If you are feeling like you're on top of things, or if you're feeling like you're behind and want to know how to get caught up, what I would recommend is start by going to the bottom of any of these topics, and there's a test for each one. So each time you load it, you get different numbers, and there's an answer key. But what that means is you want to try one copy, if possible, maybe print it, because it's more pleasant to work at a table with paper. But don't get rid of it before you look at the answer key, because if you close this window and reopen it, it'll be all different numbers and you won't be able to check your work. So maybe print out one copy with the answer key and one without, or look at it on your tablet or phone without the answers and check your answers when you're done, or something like that. So you can do that for shape-shifting, and you can do that for mad science. There's the test right there at the bottom, and that will let you know if you're on top of things or still need to do a bunch of work to get quick and fluent at this. At this point in the class, I would expect that for the first topic, people that have been attending all the time are pretty good at this. There might be something that needs a little more practice, but we keep using all of the things that we've done here foundationally, so we've seen them a lot. Riplop should be getting to be old hat. Whereas this newer stuff, you probably haven't practiced a whole lot yet, so it'll go slow and you might need to work on it some for speed, even if you understand. Okay, questions sort of about how class is going or where we are before we do some review of the measurement in the mad science topic.
I'm good.
Okay. So the measurement has a few things that are somewhat similar and somewhat different from each other. Unit analysis is its own thing, and that was what Brandy asked about specifically, so we'll spend time there. The polygon formulas for perimeter and area are not really related to unit analysis, so we will go over them if you need me to. Metaphorical rectangles is about polygon area. And then circles are very similar with just their own formulas. Prisms is talking about the surface area or the volume of rectangular blocks, mostly. A little bit more than that, but mostly we care about bricks, blocks. If you were to stack them up like a toddler playing, then how would you find how big those are? We haven't done anything with prisms yet, so that's new, but it's also not in the 10 exercises. So if you wanted to, you could have started the 10 exercises because we don't need that yet. Anyway, let's look back at unit analysis. And in the Jamboard, I will skip over those for now and grab a copy of unit analysis steps. So this is a somewhat tricky thing, but it's like riding a bicycle. You just have to sort of practice it a lot, and then all of a sudden it will click and you're like, ah, okay, now I got it. So I'm going to do some sample problems, show you how these 5 steps work, and have you help me by telling me what to write. If I go to the bottom, then I am not at my most awake today, but I am not yet so sleepy that I am again forgetting to change the numbers before I do your homework for you. So I will do that. Instead of 2 years, let's change this. How many years should we do that with this problem?
4.
4, okay. So 4 years is how many, and instead of minutes, let's make it hours. Okay, so we've done earlier converting things when you knew the converting rate. If we're going from inches to feet or something like that, then you either multiply by 12 or divide by 12 because there's 12 inches in a foot. And we had some tricks to memorize. Should you multiply or should you divide if it was something that wasn't immediately obvious? If you spend a lot of time doing carpentry, then that gets to be very second nature. If you never do carpentry, then you have to think about it every time. That makes sense. But what about when the problem has more than one conversion step? We know how to go from years to months. We know how to go from months to days. We know how to go from years to days. We know how to go from days to hours. But we don't know how to go from years to hours directly. So this is the unit analysis process that helps us do that. And it's a little long, but it's long on purpose because then we don't have to make any decisions. And if we don't have to make any choices, then we can't make the wrong choices. So we start by saying we will write the thing we have as a fraction. So 4 years. And that one isn't a fraction. So how do I make it into a fraction?
Over 1.
4 over 1.
Some of these problems, they give you a fraction. You're driving 30 miles per, the fraction bar is like per 1 hour or something like that. But this one they didn't, so we put it over 1. Then I'm going to write some empty rates. Can I go out of years into something I know? And yes, I can. I can go from years to days. Should I put days on top and years on the bottom, or years on top and days on the bottom?
Years on the bottom.
Years on bottom.
Years on bottom. Okay, everyone seems very definite about that. Why?
Is it because it's canceling out the other one?
Yeah, I can't cancel things unless one is on top and one is on bottom. So that's how I arrange it. Then, as I am doing this, I'm also going to fill in numbers for the rates. There's 365 days in a year.
So
Now-
why is the days on the top? I guess that's what I'm confused about.
Oh, okay. Days is on top because I know how to get from years to days. Whoops, that's not a laser pointer. So I need to put something on top. I'm going from years to something. I could do years to weeks. There's 52 weeks in a year. I could do years to months. There's 12 months in a year. But since I'm trying to get to hours, I'll get there as close as I can, and days gets me the closest.
Okay.
But I'm not done because I'm not in hours. So can I get to hours from days? Right now I'm in days. That's not crossed off.
Yes.
Yes. So I can say I know how to get from days to hours. And just like before, I want one of these things on top and one on bottom so that they can cancel out. Now all I have left is hours, and that's what I want. So I'm done with my blue. I've written enough fractions to get me where I want to go. And I'll also fill in that there's 24 hours in one day. So this seems a little unnatural. Why would I want to just multiply fractions to try and solve this kind of word problem? But it makes sense if you think about all these conversion rates as rates. Remember, rates and ratios, we like to write them as fractions because we know how to do math with fractions. So even though this isn't really a fraction, it's not like we have one whole that's a year and 365 parts of it. It's not like 3/4 of a cake or something like that. We can use the comparison, this per that, treat it as if it's a fraction, and it works well for our math. So that works. But the process was just, I want to get rid of years. I'll put years down here. How close to hours can I get? I can only get to days. I keep going. I'll get rid of the days. Can I get to hours? Yes. Then I stop. Does that all make sense so far?
So the one diagonal from it will always be the same, like the days. The one across from that one is days. So it'll always be the same. Does that make sense?
Right. The reason you
Okay.
add another fraction is so you can cross off a word that you don't want there.
Okay.
So tangentially, why am I allowed to do this? I can't just multiply a number by 365. That changes the answer.
Do you divide?
I divide. I'm going to wind up multiplying and dividing.
You multiply the 4, 365, and 24.
I will, yes. When I multiply for my next step, then on top, I'm going to have 4 times 365 times 24, and the only words that's left is hours. And on the bottom, I'm going to have 1 times 1 times 1 times 1 doesn't change anything. And whatever that is, let me calculator. So 4 times 365 times 24, 35,040. And then my last step is I do top divided by bottom. In this case, it's really easy because the bottom is 1 and divided by 1 doesn't change anything. But sometimes you have a number on the bottom, so I'm just writing it to be complete. And I'm done. Okay. Questions about my yellow or red?
No.
No.
Okay, so back to this part. So how can I do this? I'm not allowed to just multiply a number by 24 for no reason. And I'll give you a hint. How do 24 hours and 1 day compare?
There's 24 hours in one day.
Yeah, the top and the bottom are really the same size. How about this one? 365 days in 1 year.
The same thing.
Same thing. So how big is a fraction if the top and the denominator are the same?
1.
1, right? If I write a fraction like 28 over 28, that's going to be 1 because the top and the bottom are the same. So all of these things that I wind up multiplying by are really just 1 written in a very confusing way. So that's why I'm allowed to do it. I can take something and multiply it by 1. That's completely legitimate.
Okay, that makes more sense.
Okay, another one.
5 over 365 is the same as 365 over 1?
Well, 365 days is the same as 1 year. If I wasn't changing my units, then it wouldn't be equal to 1, because 365 as a number is certainly not the same as 1 as a number. These blue and green fractions are only equal to 1 because I am having different words as well as different numbers, and they're balancing out. Oh, okay. Let's do E here. Okay, so somebody drinks 15 cups of coffee a day. My goodness. How many gallons per year is that? So same steps. I'm going to start with writing what they give me as a fraction. What should I write?
15 over 1.
Yeah, if all I write is 15 over 1, I'm going to confuse myself.
15 cups over 1 a day. Is it 1 day?
Yep. 15 cups per 1 day, every 1 day. Right? Think of the fraction bar as one of those words. So that's how we start. Okay, now I want to change things. We want gallons per year. So I need to go from cups to gallons. And do I know how many cups are in a gallons? We should after the first topic. If we don't, let's go peek and see. So in the units and their history, there was this chart where there's 16 cups in a gallon. Does that look familiar?
Yeah.
If so, great. If not, go back and look at it. Okay. So, whoops, wrong way. 1 gallons, 16 cups. Oh, okay. So I have gotten rid of cups. Right now I have gallons per day, but that's not what I want. So I'll keep going. What words should I write in my next fraction?
Gallons
Day
on
on
the
the bottom,
bottom.
year on the bottom.
So day and year, and I heard year on the bottom. So first I'm thinking I want day on top because this day is already on the bottom. So to cancel it out, I want 1 on the top. Then I'll put in my numbers. There's 365 days in 1 year. So once again, if it helps you, you don't have to think of it this way, but these are just equal to 1. They're the same on the top and the bottom, and that makes fractions equal to 1. Okay, now I've done those steps. It's time to multiply. So on top, I have 15 times 1 times 365. If you want to write the times 1, you certainly can. And the only word I have left up top is gallons. On the bottom, 1 times 16 times 1 is just going to be 16. If you want to write the ones, you certainly can right there. And the only word that's left on the bottom is year. So what is 15 times 365? 365, 547.
5,475.
And then at the very last step, top divided by bottom. So answer divided by 16.
342.
2. This is certainly not a realistic problem. So if you wanted to round it to like 340 or something, you could, but 342 seems reasonable. 342 gallons per year. So those are the 5 steps of unit analysis. Write what they give you as a fraction. Multiply it by 1 several times, which has 2 steps. Make the words cancel until you have what you want on the top and on the bottom. And then fill in the numbers to make it true. Then multiply across the top, multiply across the bottom, because that's what we do with fractions. And then top divided by bottom to make it one number. Questions on either of these 2 examples?
I think I'm good.
I'm good.
Okay. Is this new to you, Cheryl? I'm not sure where you are and you're catching up.
Yes.
Yes. Do you want me to do another one?
No, I understand it. I just didn't know what the cups per gallons and stuff like that.
Oh, okay. If you're ever at a loss, you can always just search on the web, cups per gallon, and it'll tell you.
Yeah, we're not supposed to like have that memorized, right? Because
You need to
okay.
memorize all those conversion rates. Even if this was a normal in-person term, you would be allowed to have notes for the final. So one of the parts of your notes would be to write out all those conversion rates. You are not needing to memorize them. I am unsure in the GED if you need to memorize them or not. So that might be something to check on with the ABSE office. So I would hate to have you show up to the GED and get in trouble because you didn't have them memorized. But I'm assuming you don't, because otherwise they would have me make you memorize them, right? Okay, let's do these order of operation review things. We were talking earlier about PEMDAS. And how to think about it correctly. You want to keep 2 things in mind. One is that multiplication and division and addition and subtraction are their own single things. It is not true that multiplication and division one has higher priority than the other. They have equal priority. Addition and subtraction have equal priority. And if it's ever just the two of them, then you want to go left to right for those types of things. Also, their parentheses is really the same kind of thing as fraction bars. So think of fraction bars in parentheses as one thing, and we'll get to that with number 7. So number 3, where will I start? I'm sorry, not number 3, number 5. I'm looking at it.
Parentheses?
Yeah, let me move these over here. So parentheses, the 3/5 is just waiting its turn. So what is 1/6 plus 1/4? I'm going to kind of go off to the side and do that in a different color because I don't want to fill up this space right here with a bunch of squish. So 1/6 plus 1/4. I'm leaving some space on my paper because I know I'm going to write some things here to make a common denominator. For adding and subtracting fractions, you need a common denominator. Okay, what can 6 and 4 turn into? That's small and the same.
12.
Well, so a times 2 and a times 3. If I do it to the bottom, I have to be fair and do it to the top. And I wind up with some 12ths. How many? 2 of them plus 3 of them is 5 of them. You want me to write that out in more steps, anybody, or is it okay
Yeah.
if I squish? So this is 2/12 plus 3/12. And then when I add it up, I get to have 5/12. Okay, so that goes here. Questions so far?
No.
Do you have to have a common denominator for subtracting also?
Yes, adding and subtracting.
Okay.
And if you want to know why, we talked about that right at the very beginning of the mad science topic here. So go back to those topics.
Yeah, I remember that in school.
So no one is going to ask you in the GED or a game show to explain why, but it's not like you can't understand why. But if you, at the very least, remember multiplying, you don't need the common denominator. Right? Just multiply across top and bottom separately, but for adding and subtracting, you do. Okay, now we're just multiplying 3 times 5, 5 times 12. If you want, you can just multiply. 3 times 5 is 15. 5 times 12 is 60. We'll say, oh, that's kind of big. I'm going to do some divided by,
16.
whoops, I wrote 16 instead of 60. I am sorry, that's me being confused. Okay, thank you for catching that. Divide by 5, top and bottom. And I get 3 over 12. And I say, wait a minute, that's still not small enough. So I'll divide by 3, top and bottom, and get 1/4. I'm going to actually move this to the next slide because we're using lots of room. But that's the long way. What's the more efficient way to do 3/5 times 5/12?
Canceling.
Canceling. So I can say, let's cancel the 5s. 5 divided by 5 is 1. That's a terrible looking one. And I can say, let's cancel the 3s. 3 divided by 3 is 1. 12 divided by 3 is 4. And then when I multiply across, 1 times 1 is 1. 1 times 4 is 4. Get my answer much more quickly. If I was to color code better, what color should I make this?
What do you mean?
I mean, I want to make these yellow things match the colors in the second way of doing it.
You would make the 5s green and 3s red.
Yeah, those two 5s are green because my green canceling is those two 5s. I'm dividing by 5 top and bottom. I am just doing it before I multiply so that I don't get these big numbers like 60. And the 3s I'll make red because those red cancel marks are those divided by 3s. 3 divided by 3 is 1, 12 divided by 3 is 4. I'm just dividing early so I don't have big numbers like 60 on the page. In any case, both ways work. If you don't like having to think about canceling, you can just get the big numbers and then reduce a lot. Or you can do canceling and use up less space. When I'm canceling my words, same thing. Since canceling is just reducing early, I can only reduce if I have something on top and something on bottom. That's why I have to have one of the years on top and one of the years on bottom, because I'm canceling early. Or reducing early. That's what canceling is. Okay, one moment. Let me move this. A little bit. Just because of how that sort of appeared on the page. Okay. Okay, questions about number 5?
No.
Okay, number 6. I have 5 times something. So I need to do a 1/2 times a 1/2. Again, I'll do it kind of off on the side. I don't need common denominators. I'm multiplying. So I don't need to put some space between my fractions and my multiply sign. So multiply across the top, 1 times 1 is 1. Across the bottom, 2 times 2 is 4. And there we go. Oops. Then 5 times a quarter, how do I do that?
4 times 5 plus 1.
4 times 5. No, that would be 5 and a quarter. That's a mixed number or a plus.
Put the 5 over 1
Yeah.
and then multiply.
Talk about the difference after I do this. Then 5 times 1 is 5. 1 times 4 is 4. I can't reduce that. I'm done. Okay, let's talk about that 5 and a quarter. So if I have 5 and a quarter, that's the same as 5 plus 1/4. If I'm drawing a picture of that, I have 5 things that are wholes. And then I have another thing that I only have a quarter of it. And if I wanted to simplify that and make an improper fraction, which I'm not always sure I would agree is simplifying, then I could do what was just mentioned, 5 times 4 and then plus 1, and I get 20/4. Oops. Where are my 20/4? Well, I can take each of these and chop them up into fourths. Whoops, 21/4. No one caught me. 5 times 4 is 20, plus 1 more is 21. Okay, and now if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21/4. Everyone okay how these 3 things are the same?
Yeah.
Yeah.
So the other thing we did was 5 times 1/4. And actually, I'm going to write that as 5 copies of 1/4, make the times over here to kind of correspond with the plus. And that's saying that for some reason, I go to a party and there's 5 kinds of pie, and each pie, other people at the party ate 3/4 of it, and there's only 1/4 left. So 5 copies of 1/4. Very different picture. And so that's why when I multiply, I put the 5 over 1, and I just get 5/4, because when I count them, 1, 2, 3, 4, 5, there's just 5/4. There's not 21 of them anymore.
So you put 1 as the denominator on the 5 and then multiply?
Mhm.
Okay.
Because whenever I want to multiply by a fraction, I need a fraction, so I can go across the top and the bottom separately. And the way to make the whole number a fraction is to put it over 1. Okay, so those are very different things, top and bottom. Questions about that?
No, I got it.
Okay. So we've done these two. Number 7, maybe it'll fit that way. Okay, so this one is, I have 2/3 plus 4/5, and all of that is thirds or divided by 3 or per 3 or something like that. So when we had this little PEMDAS fix, then we commented that fraction bars can always be represented as parentheses if we wanted. So this one we're going to say is 2/3 plus 4/5. And then when we're done with that, we're dividing by 3. If you haven't seen that before, that might look really weird. Any questions about how I rewrote that to be something without a giant fraction bar?
No.
I'm good.
If it helps, think about just like a fraction 4/5 we know is 4 divided by 5. I can rewrite a fraction bar as a division symbol. That's all I've done. This fraction bar became this division symbol. Okay, now I need to add those two fractions together. So I can multiply by 5 and 3, get 15 on the bottom. If I do it on the bottom, I have to be fair and do it on the top. And I wind up with 10/15 plus 12/15 divided by 3. That's going to be 22/15. Now, how do I divide a fraction by something?
You would put it
one under the
3 over 1, and then you would flip the second fraction and multiply.
Exactly. So I say that's 3 over 1. And then I'm going to flip the second one and multiply. Okay, that's another thing, like when do you need common denominators or not, that if you just memorize how to do it, that is great. You can understand it. When we talked about fraction division, then we go into this thing about making piles of equal size and ripping up papers and things, and it's something you could understand, but if you just want to memorize it, that's fine too. So 22 times 1 is 22, 15 times 3 is 45, and we're done. Questions on number 7?
I'm good.
I'm good.
8 is so similar. Let's save 8 actually. And when we go on our break, we'll have it here on this slide. And when we check in after break, then we'll see if we can all agree on what the answer is. Okay, 9 looks like we're putting lots of things together. So I'm starting with parentheses. My 4 times is just going to patiently wait for whatever's here. And here I want 7 plus 2.5. So let's do it off on the side. This is when we have a mixed number, 2 plus a half. By the way, that is really confusing because if I have parentheses, then being brushed up next to it, like they're invading each other's personal space, means multiplying. I could write this as just 4 parentheses 7 plus 2.5, right? So it is different. This means multiplying, this means adding. That's just how mixed numbers work. So if no one has ever pointed that out carefully, now you have seen that. Okay, anyway, 7 plus 2.5. So 7 over 1 plus 2 times 2 is 4 plus 1 is 5 halves. How do I get those addable?
Common denominator.
So 14 halves and 5 more halves is 19 halves. So all of that is just getting me to put 19 halves right there. Now, it is not your job to become little copies of me. I'm going to tell you why I'm writing things, and I advise you to copy me, but they're not wrong just because you don't make your paper look like mine. One thing you may have noticed is every time I do crossing out in a problem, I switch which way my lines go. So I can always tell which things cross out with each other. With the words, it's pretty obvious, but this kind of thing, it's easier to go back a few weeks later when studying for the final if you've made your cross out marks distinct. And you probably aren't writing with fancy colors, although I certainly have had plenty of students that do. Another thing is putting space so you can make your fractions have common denominators. And then lastly, don't try and do this addition right here. I did it off on the side, so I have lots of space. I want my flow to be what's happening with PEMDAS, not how I got from one thing to the next. Okay, anyway, 4 times 19 halves, so 4 over 1 times 19 over 2. Anyone want to cancel?
2 and 4.
2 and 4. Because who wants a whatever that would be? 4 times 19. That's a bigger number than I want. It's going to be what, 80 minus 4, so 76. But I don't want 76. I'd rather just have 20 and 20 is 40. That's too big by 2, so 38 over 1, which is 38. For all of these sort of things, our calculators can just do them. So you need to be able to do them yourself, because on the GED, it's going to ask you to write this all out in steps. But it's good to check your answer. There's nothing wrong with taking a fancy calculator. And if you don't own one, then just use this one linked at the top of all of the web pages. 4 times parentheses 7 plus 2.5, 7 plus, can it do 2.5? No, it's not going to know that. So you have to know how to get from the 2.5 to 5. Whoops. Oh. And get 38 right there. Right? So it can do these almost all the way. I guess you could make this 2 plus 1/2 That's the best it can do. For the previous one, 2/3 plus 4/5. 2/3 plus 4/5. Whoops, nope, it's missing up that. So I guess you need the parentheses. 2/3 plus 4/5. Divided that by 3.
I just found out how you can do the 2 1/2 on that calculator. You would press 2 and then that arrow,
Yeah,
and then you put A over B, and it gives you the 2 1/2.
AB over C on your calculator. I don't think it has one on this.
No, on the front, right above the arrow, there's A over B.
Front, right.
Oh,
Ah, this one. Okay.
so you'd press the arrow underneath that, and then you'd press the A over B.
Like that. Okay, that A over B. Interesting. Nice. Thank you.
You're welcome.
And then I think this button changes it to a fraction. So you can check your work that way. Unfortunately, this very nice calculator isn't the one you'll use on the GED. You want me to speak a moment about the GED calculator?
Yeah.
Yeah, okay. So if you go to our wonderful syllabus, one of the things it talks about at the end is the GED. If you haven't read the syllabus, please do. It's week 6. And one of the links is the formula sheet. It will tell you all of the formulas it gives you. So you don't have to memorize all of these geometry ones that we're doing. Another thing it links to is the calculator. So here is a link to buy the calculator, which I don't recommend. And here is a link to the website that lets you practice using it. So you click up here where it says calculator or next, and it talks about this. You can open this up and try all of these things. So 2/3 plus 4/5. 2. Is it not letting me click? Oh, I see. They're wanting you to actually move along to where it wants you to test it. Okay. 2. Nope. Now is it letting me? Eventually it lets you actually click the right things and practice using the calculator. So sorry, that's not easy to demonstrate. I went through it following the directions, so I never actually noticed that if you don't follow the directions, it doesn't work. But that's right there, that link on your syllabus. Okay. Let's look at the homework for measurement because someone wanted to do that. Are there other homework problems here that you want me to do? For review?
10, please.
10?
Yeah.
Okay, let's do that. That is great because we've barely talked about circles. It's a good thing to review circles. Okay, reviewing circles. So I go to circle, circumference, and area. If you weren't here the other day, I'm going to go real quick. So we have, imagine a green thing that stabbed you in the arm and went right through the middle of your arm and measured how tall your arm was. Then that length from side to side, right through the middle, we're going to eventually give a name, the diameter. And the question was, if you had a string that long and tried to wrap it around the outside, then how many times would it wrap? Or if you stabbed yourself from ear to ear and had a string that long, how many times would it wrap around? And it's really fun in class to actually hold up a string in front of your neighbor's face. Don't actually stab them, of course. Try and make a string that's as long as ear to ear, and then wrap it around their forehead and see how many times it takes. And if it was actually circular, which heads and arms are not, then we get this thing that says circumference is pi times diameter, this formula here. And you can see it in this nice animation from Wikipedia that there's a circle and the distance across it needs 3 and a little bit of those. So there's the distance across from 0 to 1, and it takes 3 of those and a little more. So pi is just the name of that. So let me put that on our Jamboard. That's not what we need quite yet, though. So we have that this distance is called the diameter. Going all the way around. Oh, you can't see that. Going all the way around is called the circumference. I'm not sure why we need another word because perimeter was great, but there we go. And then we have this formula that says that the circumference is pi times diameter. And this is just the definition of pi. It is saying if I took this string, I would put it once, I would pick it up and put it a second time, I would pick it up and put it a third time, and then a little bit more than 3 is how many strings it would take to go all the way around my circle. So what do we know about pi? It's the answer to that. How many diameters does it take to cover the circumference of the circle? It's different than things like the area of a trapezoid. That was like a real formula. We had to figure it out. This one, whatever the answer is, we're just naming it pi. There was one other thing on this picture, and that was if we are going from the middle of the circle to the edge. What was the name of that part?
Radius.
Radius. So the radius is half of the diameter because there's the other half right there. So that's my whirlwind summary without being able to play with strings with your neighbor of what diameter and circumference are and how they fit together. Then we kept going, and now we got to something that was actually amazing. If we had a square and labeled it r times r is r squared, and then photocopied it 3 times, so we had 4 of them total, and then we put the biggest circle we could squeeze into that 4's part square. I can go straight up and down better. So each of these little squares is r times r is r squared. Do that without covering one of them. There we go. So how many of these r squareds does my circle cover when I fit it in the box? It's not all 4 because I have little bits that stick out in the corners.
About 3.
It's about 3. It's a little more than 3. And it just so happens, for reasons that you are welcome to consider magical, although they're interesting when you learn enough math to prove it, that the answer is the same thing. It's the same number that's a little bit more than 3. Which is great, because then we can have only one pi key on our calculator. If this had a different answer, then we'd need something else. If it was 3.2, then we'd need a 3.2 key on our calculator or something like that, right? But since the answers match, then we just need one key for this number, 3.14159, blah, 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 blah. So when we have the formula area of a circle is pi times r squared, then that's what it's saying. That how many r squared boxes does this circle cover? A little more than 3 of them. Okay, questions about any of that review?
I'm good.
Okay, now let's actually do our problem. So it's saying that the diameter is 14 feet. I want the area for a circle. You don't have to use subscripts. I just like that. And I like writing it pi times r times r. I talked about that before. If you like r squared, you can. I'm just doing it that way. I want to plug things in. This isn't hard. I'm good at plugging things into formulas. What do I plug into the r here?
7.
7. The radius is half the diameter. So that means the radius is 7 feet. And these are always going to be rounding. So pi times 7 times another 7 gives me about 154. How do we label our answer?
Feet.
Feet, almost. It's going to be square feet. If you like writing it feet squared like that, you can, but I'm not going to. Some people find that confusing. So what this is saying is if I had a little square foot, it would be actually in this particular case 1/7, right? If I was good at art, I could break this up into 7 boxes. But imagine I have 1 square feet. How many square feet does it take to cover my whole circle? 154 of them. Let me see if I can make my little picture a little better. Can you imagine taking this r squared by r squared thing, chopping it up into 7 equal pieces on each direction. And then one of those squares is a square foot, because this was 7 feet by 7 feet, right? Radius was 7, we decided. So how many squares this size does it take to cover my circle? 154 of them. When we did unit analysis, we were canceling out words using math rules. We can do the same thing sort of here. If I put in a feet and a feet, then when I multiply, feet times feet is going to be square feet, which is why some people write it with an exponent, because I'm doing feet times itself. And that's what 2 means, is times itself, right? When it's an exponent. So if you remember to put the words feet in, that's a reminder to yourself to put in square feet as an answer, because you will get tricked. If you want circumferences, those are in a linear measurement. We're putting a string around this. It's inches or feet or something like that. It is not square anythings. But area, we're trying to shade it in. So that's square things. We have to put tiles down in the bathroom to cover the floor. Okay, that was a lot of talking just for this problem 10. Questions about it?
I'm good, thank you.
Okay, so read more if you want, do some example problems. Let's do this one actually. So there's something vaguely shaped like a basketball court. And I want to find the perimeter and area of it. Where would I start?
The perimeter, the distance around the edges.
It is. My reminder when finding the perimeter is to pick some place to start so you don't forget any edges or double count anything. And my recommendation for these sort of puzzly problems is to not write any numbers right away. I'm going to say that first I'm going to go across the top, then I'll go down, then I'll go across the bottom, and then I'll come around that half circle. And I'm actually going to write as a formula. I'm going this way, then I'm going that way, and then I'm going this way, and then I'm doing that. And adding those four things up. Make my plan in my head before I start worrying about the numbers and the formulas and things. Right? We're doing mad science. We want to be adding, squishing things together and see what comes out. So think about which things I'm squishing together.
Is the perimeter the same as the circumference if it was the same shape? Or is
Yeah.
circumference just a
Circumference is just a fancy name for perimeter when all you have is a circle.
Okay.
That's an artifact of history. Unfortunately, we have another word to memorize. Okay, so most of these are pretty easy. How much is my going across the top?
4.7 inches.
4.7. Going down,
2.9.
0.9. Going across the bottom,
4.7.
4.7. And now the half circle. This is trouble. So if I went all the way around the circle, then I would have circumference is pi times diameter. What's the diameter of this circle?
2.9.
2.9. Everyone agree and see why?
Yeah, why is that?
This matches that. So pi times 2.9. So about 9.1. I'll go to 2 decimal places, why not? Do we want to go all the way around the circle?
No.
No.
No, we only want to go halfway around, right? This far. The outside of our original shape does not include the second half of the circle. So we're going to have here 9.11 divided by 2. Everyone okay with that?
I don't
I would
understand.
actually myself not want to write it like that. I would say something like, so halfway around is 9.11 divided by 2, which is about, and then on here, previous answer divided by 2, 4.55, 4.56, something like that. And then I would put that here. Again, I'm very big on break up the steps in little parts off to the side. That way, when I come back in a few weeks and try and use this to study for my final, I know what's happening. writing a little more explanation isn't going to hurt anything. But whatever you do, as long as this works for you. Okay, we're almost done. Now we just add this all up. So I'm going to take my previous answer and add 4.7 and 4.7 and the 2.9. When I'm adding things up, does it matter what order I add things? No, not if that's all I'm doing. So about 16.86. How should I round this? That's an interesting question. When we talked about rounding in the very beginning, we came up with this general rule for rounding that was, it's not in a box. Nope, they didn't put it in a box. Okay. So in conclusion, if there's a measurement tool that tells us how much to round to, then do that. And if I'm using a ruler, I know about how accurately I can measure, probably the 1/10 of an inch, but not the 100th. But when division is the source of our decimal, which that's what we were doing, right? Here's where the decimal came in because we were dividing things. Pi is also like that. Then don't add more than 1 decimal place than you have in the original values. You're exaggerating how accurate you know the answer. So this shape was measured to the 1/10 of an inch. So my answer I could do to the 1/10 of an inch, make that a 0.9, or I could add 1 more digit like I did, but I probably don't want to add more than that. If I wrote 16.8553, then that 5 and 3, I'm kind of bragging. I don't think my original numbers are necessarily that reliable. This might have been 4.7, it might have been 4.68, it might have been 4.72. It was only measured to 1 decimal point to start with. So to claim that we know more than 1 decimal place is already slightly suspicious, but I am perhaps careful. Maybe I can add 1 more decimal place. I don't want to add more than 1 extra though. So take the number you have in the original problem, use that or 1 more. Does that make sense as a rounding reminder?
Yeah.
Yeah.
Okay, area. I'm going to do the same thing as before. I'm going to add up 2 things, but my first line has no formulas in it. It has no numbers in it. I'm just getting my thoughts together. I have the half a circle and I have the rectangle. And my shading is dreadful. My goodness, can I do better than that? There we go. That's my plan. Everyone like my plan? I'm adding that area and that area.
Yeah.
So now I'm going to put in the formulas. So how do I get the area of a circle? Well, the area of a circle is pi times radius. And when I'm done with that, I'm going to do divided by 2 because I only have half of the circle. And then the area for, let me make that match a little better. And then the area for the rectangle is length times width. Everyone okay with why there's a red divided by 2 here?
'cause that's
Yeah.
the other half of the circle.
Yeah, pi times r gives me the wrong thing. It would give me all of this circle. And then I am going to double count the part that is both the circle and the rectangle. And I don't want to double count that. So I have to have only half the circle there. So this is fixing, because that formula is not really what I want. Okay, so my first line had only shapes, and it's okay to make an equation with only shapes. We're getting our thoughts together. My second line has no measurements. It only has formula. Now I'll finally, on my third line, plug things in. So pi times the radius of this thing. What is the radius of this thing?
Would it be 1.45?
Yeah. So radius is 2.9. That's the diameter, and then divided by 2. So 1.45. So 1.45. I'm going to run out of space. There. Okay, everyone okay with my third line where I've plugged everything in?
Yeah.
Yeah.
These are two different terms. We talked about terms. There's a plus and minus that always separate the pieces of our puzzles. So if that helps you think about things with terms, you can. Okay, everyone see the giant difference between this number and this number. This one is a measured thing, right? It is this distance on the picture. This 2 has nothing to do with anyone measuring something on this picture. This 2 is because I want half of a circle, not a whole circle. So this is part of my shapes working together. This is somebody took a ruler to this picture somewhere. And if you only do colored pens or pencils for one thing this term, I would encourage you to use them for these area puzzles, because we'll often have this kind of thing where we're just using half of a shape or something like that. And it's important to keep track that this isn't about what someone measured with a ruler. This is that the formula put out all of a shape and I just want half of a shape in this case. Anyway, now the calculator gets to do all the work. So pi times 1.45 times 1.45 divided by 2. It doesn't actually matter that it's putting it like a fraction, so that's fine. Plus 4.7 times 2.9. Now, do I need parentheses to separate these two things?
No.
No. None of our formulas ever involve adding outside of parentheses. The trapezoid formula has top plus bottom, but it's inside parentheses. So it's always true that each of these terms will be its own thing without parentheses. The calculator will know to do all the multiplication and division separately before adding them up at the end. So that's nice for us. You could always test it. I can say, let's put a parentheses here and a parentheses there. Let's put a parentheses there and a parentheses there, and it doesn't change anything. So you don't need them. Okay, but anyway, about 16.9, 16.93, something like that. Oh, I messed up. I need to label my answer. What should I label the perimeter?
Inches.
Inches. And then this one is square inches. Again, what that is saying, think about your tile in your bathroom. Oops. That I have this shape. If I could make 1 square inch, so about 1/3 of that, right, about 1/5 of that, so maybe that is a square inch. How many tiles like that does it take to cover this? And so I would make my tiles. This would go over by a little bit because it's 2.9. My artwork is obviously not sufficient. But I would take almost 17 tiles to cover that shape. Okay, questions about either of those?
I'm good.
No.
Okay, well, congratulations. That's about as tricky as they can get. Okay, let's talk about where we go from here. So we're about to talk about prisms. That's not going to take very long. It's mostly pictures. And then we'll be done with mad science. And it's only Tuesday, the first of our 2 days in week 6. So we're going to finish up the justice without needing all 3 weeks that are left. And that's good because there's a little bit more than on the justice topic that we need for level 3. We should do a little bit with graphing points and lines, and we should do a little bit with angles. I haven't prepared those yet because I'm still not quite sure exactly what to do since I can't see you in person, and without graph paper and protractors, it's going to be annoying. And I know that not everyone has a printer at home, so I can't even just say, here is a page that looks like graph paper printed out so we can have graph paper to write on. So I'm trying to make good lessons to do those last 2 level C topics of graphing points and lines and angles. They're not planned yet. But other than that, we'll be done early, which is great because we have other things to do. So looking at the syllabus for week 6, part of your job now that we are about to finish Mad Science is to start doing presentations. You're doing a wonderful job. I really appreciate how I can write on the board and you tell me what to do. Since we don't all have a copy of a little thing to write on, then that's the best that can happen. I'm your scribe. You boss me around. It would be so much nicer if we were in person and you can all take turns coming up to the board and writing things. But anyway, we can't. So what we need to do anyway, not because we're remote, but just because it's that time of the term, is for you to start making little presentations on things. You could pick something in justice. Maybe you really like cross multiplying because you're good at that. Or you're good at percent word problems, or temperature formulas are easy, or you like these kinds of area puzzles. You could do something in the playgrounds. Some of them give you instructions about things to think about. Others are just sort of a little vague. Some of them are more like projects and so on. You could play around with those and see if any of those pique your curiosity. Or we have these other 4 topics at the end, the describing data, health, personal finance, and business decisions. So you could look there and say, I want to talk about calories or heart rate formulas or scaling recipes, or I want to talk about saving for retirement because my aunt and uncle want to talk about that with me, or whatever it is. How big a house can I afford? How about margin and markup? Because I have a friend who's starting a food cart. Should I price things? Charge options, because I want to go to a store and get a dining room set, and what kind of down payment and charge option should I use? things like that. So the point of all of that is that two things will happen. One, that you will review the good math you need for the GED. That all of those little extra things I just talked, all of those applications will solidify the work we've done already this term or the stuff we're doing in the next topic with cross multiplying and stuff. So it's not a waste of time to talk about those real life applications. The other thing is that we want to recognize as LCC and ABSE in the class that you are all more than just GED students. That's probably a common reason you are all here, but that's not like the only reason you'll ever use math, or what you want to get out of this class is just enough to scrape by the GED or so on, right? You have goals, you have dreams, you have family, you have things you need. So it would be wrong to only focus on the GED topics and ignore how you are all much more than that. And so we're going to give you some choice and have you present things. Presenting things doesn't have to be a big deal. It could just be somebody saying, everyone look at this temperature thing. We're going to use the formula here and here. And remember these formulas if you haven't seen them in a while. I want the instructor to write them on the board, and then we're going to do some example problems, and you just sort of take over being the teacher in what's already prepared. Or it could be something that's very much you. Maybe you have a friend who's planning a wedding or a vacation, and you want to do the comparison one where you take a typical expensive American vacation or wedding and think about what that dream would be, and then scale it down to what you or your friend can actually afford, because most of you are young and don't have all the money of a retired person. The wealthy retired people are skewing these numbers, right? So that would be almost all you. There's not much here on this page. It's just sort of a suggestion to make two versions of a plan, a average expensive one for America and what you would actually want to do, and share about that math. So any extreme is fine. It could just be sort of you teaching for a few minutes using what's already prepared, or it could be you sharing something that was personal to you that you like. Some of these have almost no math. Which idea would you pick for a beauty contest? You're just reading about some ideas and seeing which one you think is most beautiful and tell us why. Maybe tell us about one that's not beautiful and why. A popular fun thing is a grocery shopping strategy. Grocery stores are quite different. I will often have students where a family member, a spouse, is saying, you should shop here for everything. This is the cheap grocery store. But it turns out that actually produce is cheapest at one store, and meat is cheapest at another, and frozen foods is cheapest at another. And if you really want to save money, then it's worth driving a little to the ones that are cheaper for that category. Students like that because it saves them money. Anyway, so it's up to you. Starting next time, then pick something like that. So you don't have to pick it in advance and stick to it, but I think it will be easier if you have a specific goal. So before we move on with the prisms, then let's have you pick what you want to talk about on Thursday. And 5 minutes is plenty. This doesn't have to be a giant big deal where you're up on stage for a long time. So do you want me to do a little 5-minute break and you can look at all those links on your own? I know with the Chromebooks, it's hard to watch my screen and also go to the website at the same time.
I like that.
You like that?
Yeah, I do
Okay.
have a question though.
Okay, what is your question?
For the presentation, can you only do it on the justice one and the other subjects, or can you do it on the shape shifting or mad science?
The shape shifting, I'm going to make an exception for just with prisms. Since I knew we would start this today, I didn't add a whole lot of example problems in prisms. If you want to find the surface area or volume of something else, you're more than welcome to do that. But otherwise, I don't want to have you lead the review of things. I want to challenge us, extend us a little bit, do something new.
Okay.
So yeah, don't pick something from the first topic. And for the second one, more examples of prisms is great, but let's not do more of the old stuff.
So it's mostly just for the newer topics.
I'm sorry, your microphone is fuzzy. What did you?
Is it mostly just for the newer topics then?
Yeah, newer topics.
Okay.
And it's a little bit just switching the order of homework, right? Right now, then you are saying measurement is what we went over today. So when we're done with class, I will look at all of the stuff online and do some of the 10 exercises, right? You do these topics on the website after we talk about them in class. So I'm asking you for just a little bit of something, look ahead of the time. Say, I want to talk about scaling recipes or heart rate formulas. So I'll read about that just a little bit ahead of time so I can take a turn and not a lot, right? I know that talking about math you haven't done before is kind of scary and intimidating, and I'm not wanting you to take my job and be the teacher, but it's a good thing to stretch your brain in those ways. Math is a lot like weightlifting, right? Your brain isn't exactly a muscle, but it works like a muscle. And if I can challenge you a little bit in different ways in our nice, friendly, safe environment, then that will make you stronger for the GED and afterwards.
So we're just going to be walking everybody through basically a topic.
Yep.
Okay.
Right. Today we have what, 5 people here. Someone else was here briefly. So if we have 6 people and they each take 3 or 4 or 5 minutes, that's maybe half an hour. So the plan is, how this has worked in the past, is we will do less review of the old things if we're sort of using those old things in new ways to keep us fresh. And when we get to the final at the end of week 10, then there won't be as much review because we've been seeing all these new ways that things are used. And these are also kind of very traditional applications. I would not be surprised if on the GED there was something about scaling recipes, or something about saving for retirement, or something about planning a vacation, right? So seeing this now, it's not a distraction from your goal.
So are we just like picking an equation or something to do on the board, like just one?
Yep, just pick one little thing for a class next time. And
Okay.
I expect this will work well, and we'll just sort of have everyone have some sharing time each class.
Okay.
The only thing I will ask differently is that I am used to talking to black rectangles in Zoom, but when you are nervous about teaching, you're not used to being in the spotlight on stage, then it is much easier if you see smiling faces and your classmates cheering for you. So when it is, for example, Sequoia's turn up here next Thursday to talk about whatever she picks, then if everyone else would have their camera on to help her, that will be good. If not, that's okay. I know that sometimes your kids are climbing on you and you're busy stuffing your face because you just got home from a long day at work. No one wants to watch you eat on camera and so on. But it'll be nicer for each other if you will actually look like a class of students on Zoom and not black rectangles. Okay. Does this sound reasonable? It shouldn't be too big and scary.
Yeah, it sounds fine.
Sounds big and scary.
It sounds big and scary. The first time, if it sounds big and scary, then just pick something that you have done before, like cross multiplying or temperature or some easy formulas. and just lead us through them. And I'll be writing everything out as always. It's not your job to try and run the Jamboard. So
Okay.
pick something that looks like a lesson, and that's a lot easier for you than if you try and do some playground that's actually a big project. You don't have to do a big project. If you want to do a project, you can, but that's not required. That is.
If there's an example, are we just kind of making our own numbers and not copying what's already on the example?
You can steal my examples. That's fine.
Oh,
That's
okay.
I'm wanting you to do something that's in the future of our topics and not review of the old topics, so that
Okay.
we haven't seen before. Maybe towards the end of the term, we'll change that and we'll say, oh, sure, if you want to review some shape-shifting stuff, you can, but we haven't done that in a few weeks. Let's see if there's something that's gotten rusty because we haven't happened to talk about it. And let's review that before the test. But then, yes, you should make up your own examples because we already have the other ones in our notes. So that would be, it's more work to do review than to talk about a new thing. You can just steal my stuff for new stuff. Okay, anyone already know what they want to talk about? I'll type it in the Zoom chat if you do.
I think I do.
What do you want, Savannah?
Under the justice one, and it's under one-step equations
Okay,
in problem 1.
one. Okay. So it doesn't have to be big, just a little bit of introducing it since we haven't talked about it yet, and an example problem. That's great. Anyone else know already?
I don't really understand what you mean by presentation and what we're using for it.
Okay, I want you to pick some topic that we haven't quite gotten to yet. Right? Some of these things here, probably the ones at the bottom, the 4 categories, and teach us a little something that we haven't seen yet. Put some of Cheryl into the class and not just that you are guiding my pen on the Jamboard by helping me know what to write. And if you have had trouble with attendance and are sort of new to showing up, if you don't do one Thursday, that's fine too. If it takes a little bit of time to settle into Zoom, I understand.
I might want to do the percent sentences, but I'm still deciding.
Okay. Well, why don't we I'll stop sharing because a lot of people on the Chromebooks have trouble with the sharing and the website at the same time. And let's take a little break, stretch our legs, check on kids, whatever. It's 7:40. So I'll see you in 5 minutes at 7:45, and then we'll go on to Prisms. Does that sound good?
Yeah.
Okay.
Yeah.
I'm going to pause the recording and back from break. Some students picked things to share next time, and we also had this problem we are going to finish up together. So tell me what to write. How do I simplify this one? Do you want me to put the PEMDAS thing on the top corner again? Does that help? Okay, where's one of those? There it is. So what's our first step?
I started with getting a common denominator for the 5 and 10.
Okay, so the bottom part was a 1/5 plus a 3/10. And what common denominator did you get?
10.
10. So that's a times 2. If we do it on the bottom, we'll also do it on the top. The 10 is already a 10. So 2/10 plus 3/10 is going to be 5/10.
So then I
Okay.
got 5/6 divided by 5/10. And then to do that, you would switch the second fraction. So it would be 5/6 times 10/5.
Okay, I'm going to actually write something you didn't say. This giant fraction bar turns into that division symbol. Okay, but then yes, we take the second one and flip it just like you said. Okay,
And then I canceled the 5s, put 1 for both, and then also canceled the 6 and 10 because 2 goes into both of them.
Mhm.
And then multiply it across.
perfect. As a last comment, we could have reduced here and turned 5/10 into 1/2. Sequoia didn't, and that's fine. We wound up using that 5. So reducing in the middle of a problem is not always a shortcut. Sometimes it is, sometimes it's not. Thank you. Questions about this one while it's on the board? I'm going to put my stuff here in a cloud. Oops. Say that goes there. Okay. So we're now talking about prisms. Yay. So a prism is a three-dimensional shape formed by taking a polygon. Remember, that is a shape you make by having a bunch of, whoops, straight lines. Doesn't have to be a pretty shape. And then we want to make a copy of that. And then we're going to connect the matching corners. And what I drew looks now a little too ugly and complicated. But anyway, that's the idea. Let's draw a simpler one. I'll just take a triangle and I'll take a copy of my triangle. And then I will say these corners match up. And we're making a 3D shape. We're pulling the triangle through space. We're pulling the odd shaped blue thing up in the air. So according to this definition, the copies start on the top, like or the bottom, like a floor or a ceiling, but we often will rotate it so it looks like it's coming at us instead of up and down. So you can think of a polygon like a box. We have a box, a prism, I'm sorry. So we have one side of the box. On the back, there's another side that's just the same. And then we pulled it through space, right? We made it so that the squares all connect. So when we pull it, we get more edges. So we have this edge now. There's a blue edge that looks just like that, kind of hiding in the back. There's a top that in this particular picture is open in the middle, but you can imagine it's still flat. There's a bottom that's going to be just the same, and so on. So it has all of these surfaces. And the first thing we're going to do is talk about surface area, which is just how much area do all the surfaces have. So my wife says, pardon the kitchen noises in the background. So I'm going to erase my annoying colors and label the box. So our box is 2 meters, 2.5 meters, and 4 meters. And I'm going to make a few copies of that. Okay, how much cardboard is needed for all of the box's surfaces? I'll go back to my colors. We have a front of the box. And then there's a back that looks just like that. We have a side of the box. And then there's another side behind it that looks just like that. We have a top of the box. And then there's a bottom of the box also that looks just like that. Everyone okay with my imperfect artwork?
Yeah.
So first we want the front and the back. How big are my front? How big is my back?
Mhm.
2 meters? Is that what it is?
There's a 2 meters as part of it.
And 2.5 meters.
2.5, right? I'm trying to find the area.
Oh,
I'm shading in the front and back of my box. So for both, area is length times width. I might even do area of a square is 2 times 2.5 is 5 square meters. So total of both of them is going to be 10. Twice that, because there's a front and a back. So good so far? Or so far so good?
Yeah.
Okay, green. Now I want to find how big is the area on the side of my box.
Four and 2.5.
So both sides would be twice that 10, so that's 20. We have a 10 here. We have a 10 here. So good so far. So far so good? I'm saying things backwards.
Yeah.
And then last, we have the top and the bottom.
4 meters by 2 meters
Yeah.
times 2.
Okay, when I add up everything, I have a 20. I have a 16. And I have a 10. So my grand total is going to be 10 plus 20 is 30, 46, right? Did that right in my head? Questions about the box problem?
No.
So that was kind of boring. We were doing rectangles and more rectangles and more rectangles. So let's look at this soldier tent. It has 4 feet high and 6 feet across at the base. So this is 4 and the base is 6. This tent is 8 feet deep. So this length here is 8. And it's 5 feet tall along this diagonal. Everyone okay with how I labeled it?
Yeah.
Okay, what color should I make the front of the tent?
Red.
Red. Oh, okay. Oops, it's not very thick. So we have that triangle. And then we're going to have another one of those in the back, right? Okay, how about the sides?
Mm.
Great. Okay. So we have these rectangles and we have 2 of those also. Because there's one on the back edge of the tent that we can't quite see. Okay, and we'd have to check, does this tent have a floor? Yes, not all tents do, but this one does. So I need one more color, and we're going to have a square floor also. Last time we did a kind of puzzly problem, we added up a bunch of pictures first. We made our game plan in our head. So let's do the same here. So surface area is going to be 2 of the red triangles because we have one in front and one in back. And we're going to have 2 of the green squares because there's one on the right and one on the left as we go in. And then just 1 of the blue floors. Everyone okay with my plan?
Yeah.
Okay, now we're going to put in wherever we have a shape or formula. So rectangles are length times width. What do I do for my triangle formula?
Either 1/2 times base times height or
Yeah.
base times divided by 2.
Mhm. Then I finally put in the measured numbers. So 2 times 1/2 times the base of the triangle was 6 and the height was 4. And 2 of the green triangles, which were 5 and 8. And just 1 of the blue one, which is 6 and 8. Everyone okay with me plugging in my measurements?
Yeah.
Yeah.
So 2 times a half is just 1. 6 times 4 is 24. Welcome to plug these in your calculator. You don't have to try them all in your head. 2 times 5 is 10. 10 eighths is 80. 6 times 8 is 48. Add them all up. 104, 150, 152. And these are in feet. So square feet. Ta-da. And that's really all there is to surface area. Which surfaces are there? Make a plan. List them all out. Every time there's a shape, put in the formula. And every time you have a formula, plug in the numbers. As I mentioned before, we have 3 different kinds of numbers going on here. This 2 with a yellow highlight is because we have 2 triangles. This 1/2 is because the formula has a 1/2 in it. And the 6 and the 4 are things that somebody measured with a ruler. So it will help you to keep them keep aware of how those are different types of things. But I'm going to erase my highlight because it's going to really confuse someone looking at this later. Okay, if you want on Thursday to do another one of these, you can. This picture just has some examples of how to unfold different shapes, if that helps you to think of it as one piece of paper unfolded. And here's an interesting one to try at home. If you wanted to make this triangular prism, which of the colorful shapes around it would actually fold up to make it? Some of them do, some of them don't. Can you tell just by looking which ones will work? And maybe cut them out and see if you're right or not. By the way, none of the answers have anything because this is kind of new. So if you want to make another rectangular prism or triangular prism or parallelogram prism or trapezoid prism surface area problem, you're welcome to do that as a little presentation. We need more example problems, but they are kind of long and repetitive. And once you've seen them all. When you are writing things, I encourage you to write things like me. Line up your plus signs. Keep each of these terms organized. Don't jump to this line. If you've done a bunch of them, you can. But when you're taking a test, when you have stress, when your brain shuts off a little bit, you're going to make mistakes. It's worth taking the time to write just the shapes, make your plan, to put in the formulas, and then finally, as the third step, put in some measured numbers. There's no reason to try and skip to step 3 right away, all in your head. And the last thing, which we don't have time for today after all, is volume of these. So we'll talk about that next time. I thought we would finish, but I promised Cheryl we'll stop as close to 8:10 as we can. And we're already a little over. Does anyone want to present volume for us on Thursday? No? Okay, then that's my job. So I'm going to turn off the recording and then we'll do more questions and things like that.